Hello and welcome to this video on parallel computing. I'm here to provide you with valuable insights. The voice you're hearing is AI generated, and this video is supported by the Norwegian Research Infrastructure Service. This involves collaboration between the universities of Bergen, Oslo, Tromsø, and NTNU, and working with Sigma 2 to manage the national e-infrastructure. In this video, we'll continue to explore details about scheduling jobs with the Slurm management system. More specifically, we will provide more details about submitting jobs from the Work folder. Let's navigate to the Work folder using the cd command. Notice how the command prompt changes when you execute this command. By using the ll command, we can view the folders created in the Work folder. In our next video, we will use the OpenMP on Fram folder. In this video, we will work with the Scheduling Jobs folder. Let's move into the Scheduling Jobs folder. Again, observe how the command prompt changes. We can check that this folder is empty using the ll command. Let's copy the program My Code to this folder using the cp command. Remember to use autocomplete, as demonstrated in our previous video, comparing typing with scripting. We'll also copy the job script to this folder. Use the ll command again to verify that the copying was successful. We can clear the terminal with the clear command. The program, My Code, is executed from this work folder using the sbatch command. We notice that the job is assigned the number 592081-8. We can use the sq command with the j option, providing the job number, to see that My Code has been computing for about 29 seconds. Executing the same command again, we notice that the job has finished. Using the ll command, we can see that the job has produced a Slurm output file. This Slurm file can be viewed with an editor like Emacs. The initial output in the file comes from the My Code program. The following output is from the echo command in the job script, showing that the job was submitted from the cluster work folder. The exit status is 0, indicating that the job script exited normally and My Code executed successfully. Let's edit the My Code program using Emacs. We will extend its duration to 500 seconds. We are clearing the terminal. We execute My Code again by submitting the job script with the sbatch command. Using the sq command with the u option shows that My Code has been computing for about 29 seconds on the C8512 compute node. We requested 60 seconds of wall time in the job script, so we can confirm that the job has ended after 60 seconds by applying the sq command again. The ll command shows that another Slurm output file has been generated. Let's examine the latest output file for job number 5920-821. Inside the file, we can see that the job was cancelled due to exceeding the time limit. This happened because My Code now has duration of 500 seconds, but we only requested 60 seconds of wall time in the job script. This is what you'll see in the Slurm output file if the requested wall time is shorter than the duration of your computation. The exit status is not 0 this time. Instead, it has an exit status of signal 15. We can execute My Code again using the sbatch command on the job script, and the job number is 5920-824. To cancel the job, use the scancel command, which stands for Slurm cancel, followed by the job number. We can then confirm the cancellation with the SQ command. Let's examine the Slurm output file for this job. The file shows that the job was cancelled on the C5512 node, and the exit status is signal 15. Let's try another job script on Fram by copying it to the work folder. We'll use the Emacs editor to examine this job script. This script is designed to execute my code on the big memory nodes on Fram. On the normal nodes, we must request a complete number of nodes, but on the big memory nodes, we can run a single task on a single CPU core. Since other jobs might be running on the same node as ours, we need to specify the amount of memory to use. This specification isn't necessary on the normal compute nodes because we request a complete number of nodes, which gives us access to all the memory on those nodes. At the end of the job script, we execute my code and echo the submitting folder. If my code executes successfully, the exit status should be 0 as specified. Let's edit the My Code program. We adjust its duration back to 50 seconds. We execute my code by using the sbatch command on the job script. The job number becomes 592082-7. Using the SQ command, we can see that the job has been running for about 16 seconds on the big memory nodes. After 50 seconds, we can confirm that the job has completed. The LL command shows that another Slurm output file has been created. We can examine the output file for the job on the big memory nodes with job number 592827. The Slurm file indicates that the job was executed on the C86 node, confirming that this is a big memory node. We also see that the job used only a single CPU core. The memory statistics show that we requested 20 gigabytes of memory, but my code did not use any memory since it is merely a simulation of computing. To use the scripts and files from these videos as templates for your work, you may copy them from the Saga Linux cluster. First, move to the folder Cluster, Work, Support, Parallel, Computing, YouTube. Use the ls command to display its contents. You'll recognize many scripts and files from the videos. We can copy any of these files, but let's try copying the Fortran program MXM to the Home folder. Then, use the cd command to return to the Home folder. Verify the copy with the ll command to confirm that the program is now in the Home folder. In our next video, we will offer more details on executing jobs on Fram. So far, we have focused on performance testing for various parallel computing methods for matrix multiplication using a Fortran program. Once the testing phase is complete, you'll schedule your computation code as a production job. In the next video, we will provide some suggestions on how a job script for this purpose could be structured. I am looking forward to the next video, wishing you all happy computing in the meantime.